এখানে যখন যতক্ষণ না ইয়ে হবে গ্রিন না হবে, গ্রিন হয়ে গেলে ভালো, দেখ লাল নেটওয়ার্ক প্রবলেম, বুঝতে পারলি তো? নেটওয়ার্কটা গুড নয়, এই যে এবার নেটওয়ার্ক একটু এসছে। Hi students, today I discuss the female gametophytic development of cell of angiospermic plant body. Look, the female gametophytic development. The female gametophytic development of the female gametophytic development. I hope in the last class I told you double fertilization process. In that process I have given you actually the ovule structure, but today I want to teach you the female gametophytic development of angiosperm. Actually, how the ovule is developed within ovary. That is my question. Let's start. Actually, from megaspore mother, it is a megaspore mother. It is a megaspore mother cell. This is 12. The megaspore mother cell undergoes meiosis division and forms 4 haploid megaspore. 4 haploid megaspore are produced. Each and every megaspore actually forms ovule. So you can imagine it. Here 4 number of megaspore present. Each megaspore forms ovule. So in this case, 4 female gametophytic development structures are developed. Now I discuss from a single megaspore to single ovule how it is developed. Question: suppose this is a single megaspore. When I take a single megaspore, that development is called monosporic embryo sac development. Here monosporic embryo sac development means when a female gametophytic structure is developed from a single megaspore, that called monosporic embryo sac development. In this case, you can observe a single megaspore starts to develop. Suppose this is haploid megaspore. You know this megaspore actually develops from megaspore mother, and this process is called megasporogenesis. And now I discuss the megagametogenesis process. Out of different megagametogenesis process, I discuss now monosporic embryo sac development. So monosporic embryo sac development, if you look here, actually the single megaspore undergoes division, and when a megaspore undergoes division, that called actually the embryo sac development. Here the Here the two here the nucleus divides and forms two nuclei. This is the micropylar one. This is the micropylar one, and this portion is chalazal one. This portion is chalazal one. Each other by a large vacuole. I repeat again, when a megaspore is divided, then that called embryonic development. You remember it. So it is megaspore, but it is embryonic development. Which type of? Monosporic type of embryonic development. So this megaspore, within embryonic development, this nucleus again divides and forms two polar nuclei here, and here two polar nuclei also. And here within the center, different type of actually vacuole are connected to each other and forms a large vacuole. So this large vacuolar region actually creates pressure on polar nuclei. Why it is called polar nuclei? Because these nuclei are present on polar side. So these are polar nuclei. These two polar nuclei is called micropolar, and this two polar nuclei is called chalazal. You know this pole is chalazal. I told you in the last live class video. Now these two polar nuclei again divide. These two polar nuclei again divide and forms, the shape may be changed slightly. This is the shape of embryo sac. The two polar nuclei again divide and forms four nuclei. And here the chalazal 2 also forms four nuclei. But out of them, one nuclei comes towards the center. Okay, I repeat again. Here 4 micropylar 1 and 4 chalazal 1 are developed by a single division here. But out of 4, one micropylar 1 comes towards the center and chalazal 1 comes toward the center. I want to actually give you this drawing. Look, here the micropylar 1 comes towards the center and chalazal 1 comes towards the center. Look at the diagram. Actually the 3 nucleus remains here, 1 nucleus comes here. Two polar nuclei, this is micropylar 1, this is chalazal 1, come side by side for fusion and comes towards the center and fuse to each other. Here the embryo sac and two polar nuclei fuse to each other in the center, you know, and the remaining micropylar 3 present here as egg apparatus. I told you in the last class this is egg apparatus because the middle one is egg and the remaining two is synergid, and the chalazal 3 remains as the same here as a antipodal, okay, antipodal cell. If you look the structure, the middle two, which is the fusion of the two nuclei, and two nuclei are coming from two poles. So in this case you can observe two nuclei are coming from this two pole. So these two polar nuclei come side by side and they are coming now in this structure and they are fused to each other here. So in this case you can observe these two nuclei is called secondary nucleus. You can write it secondary nucleus. This is secondary nucleus and this portion is antipodal cell. And now the embryo sac is complete You can draw here integument portion like the ovule structure. This is the innermost integument of the structure. This is integument. You can draw another integument as a outermost portion. This is the outermost portion of the integument. This is the outermost portion of the integument. So actually now it is ready as a gametophytic development. If you look the total portion, it develops from a single megaspore. I repeat again this portion for you. Look the topmost picture here. Here a megaspore mother undergoes division and forms actually 4 haploid megaspore. The 4 haploid megaspore can develop 4 ovule. But in this structure, I start from a single megaspore. The single megaspore actually forms a embryo sac. How it is possible? When this megaspore undergoes division, it forms 2 nuclei. This is 2 polar nuclei. One is mycopolar one, another is chalazal one. The mycopolar one again divides, forms 2 mycopolar, and the chalazal one again divides, forms 2 chalazal one. Now the 2 mycopolar one again divides and forms 4 mycopolar region, and this is the 4 mycopolar region. You know, towards the bottom side, this is the chalazal region. Here the chalazal 2 divides and forms 4 haploid chalazal 1. Out of the 4 mycopolar 1 mycopolar nucleus is coming from this pole, and another chalazal nucleus is coming towards the upper side. We can see both of them are coming for fusion in the center. So they are coming now in this structure, and in the final structure you can observe it. Actually in this case that they are coming and finally fuse to each other. Look at the picture center, and here the remaining 3 which function as an egg apparatus. You know, egg apparatus consists of an egg and 2 synergy cells. These are simultaneously called egg apparatus, and here the antipodal cells which actually function as a hormone secretion, that called actually antipodal cells. And if you cover the structure and by 2 integument, this is the outer integument and inner integument, this is the outer integument and this is inner integument, that is called integumented ovule. This is the ovule, or you can say this is monosporic ovule or gametophytic structure, because this ovule actually is ready for fertilization. You can observe it. This ovule is developed within the ovary. How it is? Here, look at the picture. Suppose this is the female gametophytic structure I told you in the last class. Actually, this is the female gametophytic structure, and here ovule is developed. Here the ovule is developed as a monosporic ovule is developed here in some plants. This is the monosporic ovule, and this monosporic ovule actually looks like this. But the question, how it is developed? The development process is actually called female gametophytic development. So I hope you understand the process within the ovary. This structure is the female gametophyte, better to say ovule, and this development is called female gametophytic development. I told you today actually generally this is the monosporic development. In the next class I will teach you actually the bisporic embryo sac development and tetrasporic embryo sac development, but the source of megaspore number may be variable. Okay, so in this class I hope you will understand these topics. If have you any problem, you can write in my comment box and I will reply it. Okay.